Hello and welcome everyone. My name is Alauddin and I work for Unido as a consultant in the Directorate of Environment and Energy. And we are pleased to have you here today and get the opportunity to share and learn from each other in one of the most dominant topics nowadays, the fourth industrial revolution and digitalization, and most importantly, how to leverage its potential for a green and climate resilient economy. Briefly about Unido, it is a specialized agency of the United Nations that promote industrial development for poverty reduction, inclusive globalization, and environmental sustainability. And our work in Unido is underpinned by its mission of promoting and accelerating inclusive and sustainable industrial development in an integrated approach towards achieving the 2030 Agenda for Sustainable Development and the related Sustainable Development Goals, in particular SDG 9, to build resilient infrastructure, promote inclusive and sustainable industrialization, and foster innovation. Unido works in keeping its commitment through connecting people to projects with impact, help bridge the digital divide, link enterprises with the state-of-the-art energy and environment solutions, and we bring partners and donors together with the right programs with a strong focus on women and youth. And I think we all agree that is related to all of us, the global pandemic has created inevitable challenges worldwide, with places being affected more than others due to its vulnerability. But it also created tremendous opportunities. As we all have seen during this pandemic, the digital transformation has triggered an exponential growth for societies and businesses in this short period of time that otherwise would have taken many years to achieve. Technologies like the Internet of Things, artificial intelligence, and machine learning become more increasingly part of our daily life, helping to use resources more efficiently, enabling real-time responses to contribute to building stronger and greener economies. The digital transformation is also playing a vital role in contributing to effective solutions in energy-intensive sectors, influencing consumers and producers' behavior and leading to transformation of our energy system. Additionally, the market size is expected to grow tremendously. It's actually going to be growing from 469 billion in 2020 to 1,009 billion by 2025, and at a compound annual growth rate of 16.5%. The major growth driver of this market is actually the growing adoption of digital technologies like artificial intelligence, and it's also because of the increasing penetration of smartphones and growing demand for industrial automation. It is clear the tremendous benefits we gain from digitalization, but the question here is how to tap into these opportunities. And the answer is through cooperation and partnership. Only then we can take full advantage of the digital revolution, because achieving the Paris Agreement and the climate neutral world requires new prospects offered by the digital transformation to unlock innovation, provide new opportunities to workers, decarbonize, and generally do more with less. But most importantly, we need the right skills and knowledge to tap into these opportunities and leverage it. Having said that, I would like to thank all of you. And now I'm pleased to introduce Arloyd, a pioneer company in the field of artificial intelligence, who will today share with us their work and its importance. And I will hand the floor now to Ms. Emmy, Arloyd Executive Coordinator and our moderator for the session, to introduce our speakers and lead. And over to you, Emmy. Thank you very much.
Dean, thank you for your kind introduction to us. And I would also really like to thank the United Nations Industrial Development Organization, Unido, for their invitation for us to take part today. We're excited to share a little bit about our business, Arloyd, and what we're doing to contribute to a sustainable future, particularly in the built environment. We are an artificial intelligence technology business that uses AI to make the heating, ventilation, and air conditioning systems, or HVAC, in buildings more efficient. This, of course, leads to not only a reduction in energy bills, but also a reduced carbon footprint for these buildings. We firmly believe that AI has a critical role to play in reaching our target of net zero by 2050. AI allows us to be efficient beyond our human capacity. We can rely on machine learning and data to deliver better results than we ever could. AI also allows us to adapt quickly to changes in our environment, such as policy changes and large-scale economic changes as well. Our AI also uses large global data sets. And so in this way, we're relying on a global community really to help us achieve our common goals of net zero. We're using this global intelligence and data to deliver real results in energy saving. And before I hand over to our speakers from Alloyd, I wanted to touch briefly on the youth aspect of today. We're really proud to be presenting our session today as part of the youth segment of the Vienna Forum. And so, yeah, we know how important it is firsthand, how important youth are to the future of AI and its role in the net zero challenge. At Alloyd, our average age across the business is just 34. And in our R&D team in particular, the average age is just 33. So we're really proud to be a company that attracts young talent who are keen for not only a career challenge, but they're also really passionate about green technology solutions. We're always looking for new young talent in our business, and the industry in general as well is in real need of data scientists and machine learning experts. So if this is an industry that's of interest to you, it is really a great time to be involved. We're also nurturing young talent, not only in our R&D space, but also in our business and commercial roles. Just earlier this year, actually, we brought on 4 students in sales development roles. So the outlook is really positive, and we do need young talent in all the sectors to help us realize our net zero ambitions. So I'll be back a little bit later to moderate our Q&A session. If you do have questions, please feel free to put them in the chat and we'll get to them at the end. But for now, I'll hand over to our Chief Product Officer, Vladimir Pushman.
Hello, everyone. Very nice to be a part of this great event. So today we're going to talk a little bit about the way how machine learning can help to achieve net zero. And we will deep dive into the specifics of how it can actually help in the real estate industry. But we will start with the introduction of ourselves. I will introduce myself and Ksenia will introduce herself. So I'm Vladimir Pushman. I'm a CPO and co-founder of Alloyd. I'm actually coming from the energy consulting background. I graduated from London Cass Business School, so I have a business degree. And yeah, currently I'm leading the team, the company on the commercial side globally, as well as aligning that the product that we deliver to the market is actually solving the problem that we are set to solve. So yeah, this is my role. Ksenia, over to you.
Hello, everybody. I'm Ksenia Orshinina, and data scientist at Alloyd. And as it says in my bio, I've tried lots of other areas, and for now I decided to stay in machine learning because so far it's been the most interesting area I was working with. So, and today I'm going to talk about what I do at my job as a data scientist and what helps many industries around the world to nowadays. So next slide, please. On the screen, you might see some of the industries that use machine learning and some of the techniques that are used in machine learning. Machine learning can be refer to a set of methods in computer science, or a separate discipline, or a part of the more abstract term called artificial intelligence. Today, we're going to talk about machine learning methods, which are simply the means to get computers progressively improve upon a set task that it was given. Or in other words, machine learning helps computers learn without being explicitly programmed to do so. Largely, there are three major recognized categories in machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is the most popular paradigm in machine learning, and it is the simplest to understand and the easiest to implement. It is very similar to teaching a child with the use of flashcards. Given a lot of data with a lot of examples and labels, we can feed the data to the learning algorithm and let it predict the labels and giving it the feedback if it did right or wrong. Some of the examples of using supervised learning is selecting advertisement, which will perform well, or filtering spam. Unsupervised learning has no labels. It is fed a lot of data and the tools to understand this data. From that, it uses this data to group, cluster, or categorize and or organize the data in a way that human being can come in, or any other intelligent algorithm can come in and make sense of the newly organized data. Unsupervised learning is a very interesting and incredibly significant area, because an overwhelming majority of data nowadays is unlabeled. Some examples of using unsupervised learning is categorizing clients, or understanding client groups for building marketing or other business strategies. Also, it's used in genetics, specifically for clustering DNA patterns to analyze evolutionary biology, and etc. Reinforcement learning, on the other hand, is a fairly different concept, and when we can see the difference and the relation between supervised and unsupervised learning, reinforcement learning is a bit murkier. Reinforcement learning is learning through trial and error. You can place a reinforcement learning algorithm into any environment, and it will make a lot of mistakes at the beginning. But then, with time, and provided that we give some sort of the signal to the algorithm, which can associate good behaviors with a positive signal and bad behaviors with a negative one, we can reinforce the agent to prefer good behaviors over bad ones. Reinforcement learning is a very behavior-driven algorithm, and it has influences from other fields, especially from the fields of neuroscience and psychology. So if you ever heard about Pavlov's dog, then you are most likely familiar with the concept of reinforcing an agent, especially a biological one. So for reinforcement learning, we need an agent, an environment, and also a way to connect those two with a feedback loop. On the slide, you may also see a part that is called interpreter, but usually this is just a part of the environment. So to connect the agent to the environment, we give the agent a set of actions to affect the environment. And to connect the environment with the agent, the environment is constantly issuing two signals to the agent. First signal is a new state of the environment, and the second signal is a reward. which is our reinforcement signal for good or bad behavior. The most popular example of reinforcement learning is playing Atari games. The algorithm or agent is put in place of a game player, and it has to select actions, which are the usual actions or moves inside the game, like clicking buttons for a human. After that, the environment receives the action, and environment is actually the game. And then the game provides a reward, which is a change in score, or it provides a new state, which is just another new game frame. Also, there are other popular examples of using reinforcement learning. For example, robotic automation, which is assembly lines. It is a very good idea to make machines learn from their experience without having to hard code their processes. Also, a very good example is Google's data centers. They used reinforcement learning to provide the power resources that they needed, but they did it in the most efficient way to cut major costs. And this is also a very good area to use reinforcement learning to incentivize machines to use less electricity and to save money. And this is what we actually do at Alloyd. We use reinforcement learning to optimize energy consumption and to automate energy management for various buildings. So on the next slide, you can see the technique that we actually use in reinforcement learning. It's A3C. A3C is nowadays one of the most powerful algorithms in deep reinforcement learning. It stands for asynchronous advantage actor critic. The main distinguishing feature of A3C is that it has a lot of agents, which are workers on the slides, and a common global network which connects and controls those agents, and also multiple environments. These environments are connected to all agents, and all agents take actions in those environments simultaneously without checking on each other. Each agent has their own set of neural network parameters, which it uses, and also they periodically and non-simultaneously, they fetch parameters from the global neural network and continue working. So this way helps bring more environment states and increase agents' adaptability. And this is the first A in A3C. It's asynchronous. So going forward, the second A is actor critic, and you can see on the global neural network on the slide that the network is split in two pieces. It's policy and V, which stands for value. And they also have other names. So policy is actor and V is critic. The policy part of the neural network, which is actually actor part of the neural network, it's used to select actions and to decide the actual policy, like how to act. The value is the critic part, and it decides how good the action actually was. And the last A in A3C is advantage. And this is something that is used in A3C to tell if the actual action that was taken is better or worse than the action that we expected to be taken. All of this helps the agent work better and makes the life of the agent easier. So to apply A3C on Alloyd, this is what we actually do at Alloyd. And this is how this algorithm looks like in Alloyd. So we have a set of agents which are actually conditioners or other equipment of the heating, ventilation, and air conditioning system of the actual building. We also have several environments which are simulations of the same actual building, and the agents devices work in those environments. Each agent has two neural networks, one for taking actions and the other one for telling how good the action was. The actions, the sets or modes of each device. For example, increased temperature, decreased temperature, fan, no fan, remain the same, etc. Then each agent and each device gets an environment state, which is the information on climate control conditions inside the building. After they got the environment state, they actually take action again. Each agent uses their experience and their calculated value to choose the actions and to learn how to make their actions be more effective and get more reward. So over time, the agents do better taking the actions, and in the end, our system and the devices do a very good job controlling the climate inside the building, so that everybody who is in the building feels comfortable, and the energy consumption is at the lowest level possible. So I think this is it from my side, and Vladimir, please continue.
Yeah, so on the side of the key problem that we tackle for the real estate in general is that the HVAC infrastructure, this heating, ventilation, and air conditioning, is very static in the sense that operations teams that tend to operate the systems, they either rely on pre-configured schedules or pre-configured settings that are provided by the building automation system supplier, or they go for the change of settings by themselves. But when we talk about big buildings, especially those that we touch right now, they usually come with 300 plus connected devices, means that the person who is making the decision will definitely overlook some of the devices, or at least touch 1% of the whole infrastructure at a particular point of time. And also, in some cases, they go for the tenants' complaints. Of course, it depends on the type of the building and the significance of the building. But in some cases, and in most cases, I would honestly say is that they don't really change the settings when they see the complaint, especially in dynamic environments. However, the environment inside and outside of the building is changing dynamically. And so if these changes are not addressed, it leads to a massive energy waste or any other sources that are used to provide the work of the HVAC infrastructure in the building. And so in order to solve that problem, we developed an AI solution that was just described by Ksenia in a very detailed way. But what we do is that we automatically choose optimal HVAC settings based on comfort index calculations in real time. So in a nutshell, we start off with the building simulation, building assessment process. We do it remotely. Then we agree on the way to connect to the building, date and time. We initiate the connection to the building management system on the lower level, which takes less than an hour. In some cases, which we experienced, it took us around 10 minutes, and it does not require any interruption to the operations in the building. Then when the connection is there, we take 30 days to create a building simulation. So the building simulation is basically creating a digital twin based on the data that we receive during the assessment process. And one of the things that we do as part of this stage is we separate the building by different zones, and we establish the comfort indexes, which are different because of the different utilization of rooms. And then as a result of the simulation phase, we show the potentials for the next 30 days on optimization, also the baseline, so basically the base consumption within the space without the involvement of AI in the work, and also the insights on how exactly it's going to work there. And when the simulation process is done, we know the results, we discuss these results with the client. We proceed to the start of the savings, where we release the pre-trained artificial intelligence in the facility, and it starts to save from day one. But if you don't mind, I will share the video with a little bit more information on the processes. And then we will come back to the presentation.
Let us fill you in on how easy it is to work with us and install AI across all your premises. Our starting point is the information you provide about your building, because every building is unique. When everything's ready, we sign a master agreement to connect your property and do a simulation process for 1 month. We build a virtual version of your building in our simulator. We take all kinds of details into account, including the characteristics of all the construction materials used, location, climate, and existing HVAC equipment. When the building simulator is ready, our AI calculates your real 12-month forecast based on live data specific to your building. So you'll receive a baseline for the year ahead if you were to carry on as you are, as well as all the projected changes if you choose to optimize with AI. And we're not just talking about energy. The report also covers money saved, carbon saved, coolant saved, improvements in comfort, and more. Finally, we agree on baselines and enter into commercial so that the AI can implement all of its findings. Then you'll receive user-friendly tools to monitor the AI's work, both a live dashboard and mobile app, and our team will also be available 24/7 to help whenever you need it. Arloyd, the intelligent assistant for energy saving.
And that, I think I can hand back to you now.
Thank you very much, Shani. So with such an approach, we're looking to up to 40% optimization on utilities, then a respective 30 to 40% decrease in carbon footprint, and also a significant improvement in occupancy comfort in the building. So currently, we're working with more than 11 million of square feet of real estate, covering shopping malls, residential buildings, office buildings, university campuses, and hotels. Locations, it's in the UAE, in Singapore, in China, and we currently working on getting more buildings in the UK, in Germany, and spreading across the Southeast Asia, going to Thailand and Vietnam, and very soon going to Japan as well. So on the side of the competitive advantage, so why and where we're different from what we see on the market at this stage. So firstly is the technology differentiation. So having a base using the reinforcement is already a differentiator. But on top of that, we have a proprietary AI training method that allows us to work with limited to no historical data, which basically means that we can deliver the results much faster than the competition. If you compare this approach with the data analytics tools or rule-based machine learning techniques like random forests, they usually require a lot of data, in particular is between 3 to 6 months, and which means that what we usually see is that building management systems, they don't usually store the data, which leads to the fact that they need to start collecting this amount of data from day one, from scratch. And in this case, it basically extends the timeline for them to show the results of the optimization to the building. Then on another side is the optimization approach itself. So we start off with the simulation phase, which is the way for both us and the client to see what can be achieved based on the system that they already have in the building. And then it is also the way for the client to see it without any financial commitment at this stage and no risk. And also we utilize a full automatic control of Hvac settings, which I will give an example. So some of the buildings that we work with at the moment, they have more than 2,000 devices. And what might happen is that the AI can decide to make the changes to all of these devices at the same time, or a part of these devices that allocated in different parts of the building on different floors. And also, usually we see that it applies different settings as well because of the different comfort indices. So this is the best. So AI in this case is the best tool to execute that, because it can execute that on time and ensure that the settings that are applied, they are correct ones, while practically it's impossible to execute, especially when what we usually see in buildings is that they have one building management system, then there is only one building management system PC where the operations team can change the settings. But here in this case, we talk about thousands of devices changed at the same time. And this is basically where the optimization is coming from. It's coming from the micromanagement of these devices on various levels and frequently as well. And also on the business side, there is no capital expenditure involved, so the buildings, they don't need to invest upfront. Then the connection itself is fast and non-intrusive, which does not require any interruption of the operations currently running in the building. Plus, it allows to scale fast within the portfolio of buildings. Then there is no long contract lockup because of the avoidance of the capex. And then one of the ways that we charge the client is that we charge a percentage from confirmed savings on a monthly basis, which is a way for the client to lower the financial risk. So a little bit about ourselves, about the company. So we are a team of 52 people spread across 4 offices. So Sergey is the CEO and the founder. He is a serial entrepreneur coming from businesses in technology and real estate. Maxim Zubov is our chief technology officer and co-founder. He has more than 20 years of experience in software development. I will skip myself because I already introduced myself. We also have 2 advisors on the machine learning and data science fields. So Mark Maloney is coming with 20 years of experience in these fields on the technical side, and Kurik is coming from the same background but on the business side, but also with over 20 years of experience in data analytics. So at the moment, we are already spread across, as I mentioned, 4 countries. So our headquarters is in the UK. We have operations offices in Singapore and Dubai, and we have our R&D staff, R&D office located in St. Petersburg. However, R&D team is spread across different regions anyway. So on the closing note, I wanted to emphasize a little bit on the side of youth and how it is involved in our work, and basically our vision on that. So we split that to commercial and the technical side. On the commercial side, I would say that we split the commercial side itself to hard and soft skills. It is quite, I would say it's not a big challenge to find people for marketing, for sales, for customer success, if we judge based on hard skills. However, it is very difficult to find people with the right set of soft skills. What I mean by soft skills in this case is that we're always looking for people that are ready to take the challenges, to be under almost every day under constant pressure, since this is a startup environment. And then being able to deliver and move fast as well. This is something that really lacks on the market. I would honestly say that, since I overlooked the commercial aspects of the business globally. But when we talk about the technical side, and also just summarizing the commercial side, it's all about taking the risk and being able to manage that risk and live with that risk. But always risk comes with a big reward. But when we talk about the technical side, we don't have, I mean, of course we charge, we look for a combination of soft skills and hard skills as well. But in this case, on the technical side, hard skills is the paramount, and it is very difficult to find people who are ready to work in this domain, who have the right experience, right knowledge, and the attitude to learn as well. And so, from our perspective, It is great to find, I mean, we're always looking for people on both sides. And yeah, it's all about the priorities from your side. If you're technical, then go for hard skills, I would say. Soft skills will come. We can tolerate the absence of soft skills in some cases, but when we talk about the commercial, it's all about the soft skills. Hard skills is quite easy to find. Thank you very much.
Thanks very much, Vlad. Yeah, we now have a short time for questions, I think. So if anyone has any questions, please do use just the chat function on the side, and we will get to them. Elizabeth, I want to thank you for your question. And I think Vladimir did a really good job of touching on the importance of bringing young people not only into our business, but into the industry in general. And I touched on it a little bit earlier as well, just that there's plenty of opportunity and a real hunger for good people, as Vlad was saying, people with the right mix of hard skills and soft skills to be able to contribute to a startup environment, which is where a lot of these companies are based. So yeah, that's definitely true for us at Alloyd. I'm not sure, Vladimir or Ksenia, actually, if you wanted to add anything, maybe Ksenia, a little bit about yourself and what did you find was helpful for you, maybe in studying or learning? What courses or degrees do you think are a good fit for machine learning, or anyone interested in taking on a career in the field?
I think that one of the most classical and from one point, the easiest way is just to get a degree in machine learning or at least in maths, and then to get like master's degree in machine learning. But there's also another way, which is much faster, and you just get hands on the machine learning and the programming, and you use all of the courses you can find. But for me, something that really worked is the courses from OpenAI, from DeepMind, especially David Silver, and the classical book on machine learning from Sutton and Watteau. So these are the main courses, and then you just develop other courses that you can find anywhere, like on Coursera, there are courses in universities, just quick courses, and so on and so forth. That's it. Thank you.
Ksenia, it's really helpful. Vlad, did you want to add anything about maybe the young people that you have working in your team, particularly maybe on the other side, on the sales, commercial? What kind of things are you looking for in young people when you hire them in those roles?
I would say that we judge based on the previous experience, despite the fact that it might sound contradicting since they're students and what kind of experience they might have, but you'll be surprised that the guys that we have in our team, they're actually quite entrepreneurial already, and so they usually come with the background of doing some projects that are related to selling. I mean, they developed something or they bought something and they went to sales. This is something that we look for. So this is all about the attitude and the readiness of the person to go and actually challenge him or herself, because going for sales is always going outside of the comfort zone. It's always outside of that. Yeah, and so that's why we look for this kind of examples. We don't really look at the degree, because it's all about the ability of the person to convince someone, and so it doesn't really matter where the person is coming from. But yeah, it's all about attitude. And also we judge based on the conversation itself, because during the interview process, we rather keep the conversation casual in order to get the most of the person, just to see how people react when the discussion is scheduled, and they basically can share more and more and more. And yeah, we just try to get the right things from the conversation, and then make a decision based on that. But what we always value, and we don't really expect that from our candidates, is that they have a sense of the processes that are involved in the sales process itself or in marketing. So they have a sense of how it is structured, because there's always everywhere a foundation. So all the activities that we do, and we're a very process-driven company, which is kind of spreading across all the functions, and sales is not. It's also one of this process that we build and that we follow as well.
Great, thanks so much.
May I also jump me? I just have a couple of questions, I think. I was wondering if you think that the academic institutions is a little bit lacking behind in terms of curriculum, of like offering good curriculum, or also because I'm thinking now, because digital technologies is advancing so fast that even institutions can keep up with. So what I think is that I met a lot of people who actually taking online courses, and once involved in the digital field, they actually learn by doing. And I'm not sure if this is actually true, because I never came across a machine learning master program, but I would love to see that. So I was wondering if this is correct or not, if it's the institutions is lagging behind in terms of knowledge, and if the people who involved in the digital field are actually learning by practicing.
It seems like I'm the one to answer this question. And yeah, you are partially right, because really there is not many good universities who provide good courses on machine learning, and it's really much faster and sometimes better to just get the experience and then get the theoretics afterwards. This is actually what happened to me. But from the other point of view, it's easier to have the theoretical part and then get the practical experience on that. Besides, big universities, or like the universities who want to give the best to their students, just invite the people who work in the machine learning area. For example, David Silver is working in DeepMind, and he also teaches students at Stanford University, as far as I remember. And also other universities, they just invite people who work in those areas, and they do know what's the most effective at the time in this area. So this is when the university education may be good. Yeah, besides, machine learning is very much based on maths, and the maths so far is really very strong at the universities. Yeah.
Another question, just and I think this question is actually, I'm speaking on behalf of many people, because I got this a lot, and people actually they're wondering whether we can use digital technologies in let's say old infrastructure. They believe that we need modern and new infrastructure so we can apply the digital transformation. But I would love to hear the answer from you guys, that even with the old infrastructure, we're still able to implement digital technologies and energy efficiency measures. Is that could be
Yeah, if we talk about the solution that we provide, we charge based on different things. So we actually work with buildings that are from 70s or 80s. However, the infrastructure inside, it had to go through some sort of transformation during the course of its life. Otherwise, it would be stuck in 1970s. And so, what we require for our solution to work is the connectivity within the building. So the infrastructure is interconnected and centrally connected, which we see in all buildings. In new buildings, it doesn't really matter. Sometimes new buildings, they have a complete mess inside, don't have the infrastructure in place. which upsets us a lot. But yeah, it doesn't really matter whether it's an old building or a new building. The digital transformation can surely come on all these sides. But I would say that it's mostly one of the key prerequisites, I would say, is the mindset of people who are making decisions in these organizations. This is all about that, because what we face is that sometimes there are different ways of optimizing. One of them is retrofitting, is when you replace the devices in the building. So you take the old ones out and then you put new ones in. And this was one of the, it started to be super active in around 10 years back. So people were starting, now it's accelerated, I think now it's going down. But people that were open to new ideas at that time, when the retrofitting was in place, now they are at a later stage. And so they're still open, of course, for new things, but they still live in the paradigm of going for retrofitting rather than going for any additional things on top of that. And the buildings that we work with right now, they usually come with people who are open to innovation. So they like almost say that from day one that, yeah, we're here to transform the real estate. We're ready, we know the value, and that is why we want to work with you. Or if we face a very strong objection on the side of skepticism about the use of AI in the buildings, then we go through this. We will go anyway through the process that we mentioned during the presentation, but it really actually helps to go through that skepticism side with people that are not really ready for that transformation. So we take it like a step-by-step approach.
Thanks, Aladdin. Thanks for your questions.
Thank you.
Oh, thank you.
I think maybe
Thank
we
you
have
for the
time
knowledge.
for one or two more. Maybe just talking about that, Vlad, about old buildings and new buildings and people being kind of ready for embracing transformation. Do you find that there are certain countries or certain regions in the world that maybe have a greater appetite for that change than others?
Yes, I think one of the key drivers right now is the pledge to achieve net zero by a certain date. It's maybe 2050, 2030. So it actually drives people a lot. In some places, I would say that the Western part of the world, they're quite active on the side of ESG, which is the environment, social governance, basically the net zero. And so they're already playing in this field for some time. And they, I would say, not at the beginning of applying that. And so they have the rules inside and they have like a playbook on how to do it. So they know how to do it, and that's why they're quite receptive on things that are helping them to achieve the net zero. However, there are other regions like eastern side of the world that is also keen on, they also pledge to achieve net zero. They're also keen on ESG. However, they don't know exactly what to do, and they're very active. They really want to do it, but they try to keep up with guidelines that were developed by other countries. And so what I would say is that they're all active. However, they're all at different stage. So the western side is a bit more mature than the eastern side. However, eastern side is actually keeping up with the trend, I would say, and with this process very, very fast. And so what we usually hear is that yeah, we want to go for ESG. We want to achieve net zero as fast as we can. Just tell us what to do, how we can do it. So this is in some cases the approach here in the east side.
Fantastic. Thanks so much. Yeah, great to know there's lots of appetite and different ways of going about it, I guess, as well. Aladdin, I think we're almost out of time.
I think we're almost out of time. And I think we're not expecting new questions. And I would love also actually to just give the ending with one final question just for Vladimir. Do you think that we're actually going in the right direction do you think it's possible actually to achieve net zero without digitalization? Because currently yeah, please go ahead, because I think there's a huge gap now to do.
Without digitalization, for sure, no. Without digitalization, it's all about digitalization now. And what is interesting is to look at the perspective of different industries and how digitalized they are. And real estate itself is one of the least digitalized industries, and that is, but at the same time, real estate in general, directly or indirectly, cause around 40% of total emissions, as far as I remember. So it's quite a significant part of the emission worldwide in the least digitalized industry. So it's all about the digitalization. It's going to be tough, for sure. Especially when it comes, as I mentioned, on the side of the mindset of people that are making the decisions. What we're afraid of is that people who are pledging to achieve net zero by 2050, they will not be on the management board at that time of these organizations, because it's still a lot of time, not a lot of time, but some time until we face when we need to defend the KPI of whether we achieve that or not. And we're just afraid, it doesn't mean that it's going to happen, of course, but we're just afraid that these people are not going to be accountable for that, but they will put that pressure on others, on their peers, which actually can postpone things. But based on the response from the market right now, based on the activity that we see, it is possible, and it is possible digitalization, and gladly we see that companies are moving towards that.
Thanks, Vlad. And Aladdin, Unido, Vienna Energy Forum, thank you very much for having us.
Thank you very much for you guys.